Welcome to yet another important lesson that we are going to discuss today. This is very important because it's a basic concept that all physicists should have. For today, we will continue with vectors, but we'll look at basically the addition of vectors. We'll define what a unit vector is and then go into looking at how we can add vectors using the unit vector notation. And here we go. It's very important that learners understand vectors because vectors should be understood in terms of how we can add them as well as how we can multiply them. There are many methods of multiplying vectors, but for today, we'll just look at how we can actually add unit vector notation problems. And so this is very important because several times we interact with the problems in vector notation in physics. And so learners should have these basic concepts of how they can add vectors using the unit vector notation. First of all, we need to understand what a unit vector is. A unit vector has actually a magnitude of 1 in a specified direction. It could be in the x-axis, y-axis, and z-axis. So it has a magnitude of 1. And it is also dimensionless, meaning that it has no units. As I indicated earlier, its magnitude actually is unit. That's why it's known as unit is 1. So normally we use the notations I, j, k to represent unit vectors which point in the x, y, z direction respectively. And therefore, as I've shown here in this diagram, in the x-axis we have I, and in the y-axis we have j, and in the z-axis we have k. And all these are unit vectors, meaning they have only a measure of 1 unit. So how do we represent a vector in unit notation? A vector can be written as the sum of 3 vectors, each parallel to the coordinate. For example, vector A, we have a vector A which has a magnitude, which has a representation of the vector in the x, y, and z. And so this is how we present a vector in unity notation. And so at times we interact with problems where we have to add vectors. And so we are going now to discuss how we can add vectors using unit vector notation. For example, if we have a vector A which is represented with some vector representation in x, y, and z, as well as B. So what we need to do, you add the corresponding, the addition of vector A to B, we just see the corresponding vectors for each axis, you add them. Like for example, the vector for A in the x-axis, you add it to vector B in the x-axis. Similarly, you do the same for Y and Z. So here is a simple question that we are going to look at so that we illustrate exactly what we are talking about. For example, if we are to find the sum of the 2 vectors, that is vector A and B, using the unit vector notation form, And the two vectors are vector A is 3i plus 2j minus 6k, while vector B is negative 9i minus 5j plus 10k. So as I indicated earlier, using the vector unit notation methodology of addition, so we can go ahead and add the corresponding axis. So 3i should be added to minus 9i, which gives us 6i, which gives us minus actually 6i. Okay. And if we add the 2 minus 5, it gives also us minus 3j. And if we add the minus 6 plus 10, it gives us 4. And so this is the value that we get for the addition of vectors. This is a very important concept which appears to be very simple before we apply it to more complex physics problems because of the nature in which we have added them. However, when we miss these concepts of additional vectors, we will find ourselves in problems when we interact with more complex physics problems. The next lesson, we're going to discuss the multiplication of vectors using the unit vector notation. And I hope you will not miss that one. So you can subscribe to my YouTube again so that we can continue learning these interesting lessons at A level. Okay, thank you.